Today we're going to be learning about rational exponents. And I told you last week that in mathematics the word rational means fractions. And that's right, exponents can be fractions. So all the things that we practiced last week, the whole when you multiply two numbers with the same base, or when you divide two numbers with the same base, when you raise a power to a power, all of that stuff is now going to be applied, but with fraction exponents. And also the whole bit where we were reducing radicals, that kind of stuff as well. Mr. M, you're talking a whole lot about fraction exponents, and I'm looking at these notes, and I don't see any fraction exponents. I go, oh, but you do. You just didn't know it. You see, there is no such thing as a square root, or a third root, or a fourth root. There's no such thing. Instead, these are just a way of writing fractional exponents. As it turns out, radicals are actually exponents. They're fraction exponents. So what does that look like? Well, we had some academic vocabulary last week, right? And we talked about this number right here being called the root index. The root index is actually the denominator of the fractional exponent. So this can be written as x raised to the a over b. So this is a true exponent, this a. It's in the exponent position. That's the numerator of the exponent. The root index is the denominator of a fraction exponent. But this is not the only way this could have been written. You guys believe me when I say that multiplication can be done in any order? 2 times 3 is the same as 3 times 2, right? That makes sense? Okay. Well, this right here, this a over b, isn't it true that a over b could actually be written as a times 1 over b? Like if this said, just for example, 2/5, couldn't I have said 2 times 1/5? I could do that, right? Well, that means that I could actually have written it like this then. Right? Multiplication doesn't care about order. Well, this 1 over b is right here. This b root, if you want to call it that. What I'm trying to get at here is that I could either say this exponent is on the inside, or I could say it's on the outside. And they're still going to give me the same result. And the reason why is because the order of the exponents is unimportant. Remember, power to a power, you multiply the exponents, right? What I could have done is I could have said this was x to the a raised to the 1 over b, which is why it's x to the a over b, because when you raise a power to a power, you multiply the exponents. Or I could have said it was x to the 1 over b raised to the a. Again, when you raise a power to a power, you multiply the exponents. And either way I write it, either with the a on the x or the 1 over b on the x, power to power is still going to give me this result. What I'm trying to get you to see is that if you have a fractional exponent that has a numerator and a denominator, you can write it in either of these two formats, whichever one is more useful for you. Okay. We will get some practice and that stuff will start to make a little bit more sense, especially when we use numbers like this here. You can do this by hand. No calculator is needed. And I will show you. So let's go ahead and simplify some expressions. Let's use our knowledge of exponent rules and our newfound knowledge that a root is actually a fraction exponent. So instead of saying that this is the cube root of x squared, what I want to do is I want to say that this is x to the 2 over 3, x to the 2/3. Times, and we talked about this last week, it's not written, but what is the index of a square root? It's a 2. So a square root can be thought of as being the 1/2 power. I know there's not an exponent written on that x, but it could have been a 1. Well, I mean, it is a 1 if it's not written. So this is what that's telling us to do. It's telling us to multiply x to the 2/3 and x to the 1/2. Now thinking back to last week, on Monday and Tuesday, we practiced our basic Algebra 1 exponent rules. When you multiply two numbers with the same base, what do you have to do with the exponents? I'm sorry? You need to add them. I can't just add 2/3 and 1/2. What do I need in order to add or subtract fractions? What do you have to have? The same denominator. I need the least common denominator. So I'm looking at this 2/3 and this 1/2. And what I'm going to do is I'm going to do this math down here. I'll just focus on the 2/3 and the 1/2. Because that's the issue at hand now. I need to be able to add these fractions. I need a common denominator. What is the smallest number that you could divide by 3 and 2? Not what you can divide them by. What's the smallest number that could be divided by the 3 and the 2? 6. 3 and 2 will both go into 6. So what I need is I need the bottom of this to be a 6, and I need the bottom of this to be a 6. The only way that this 3 becomes a 6 is if I multiply it by 2. But if you do it to the bottom, you have to do it to the top. And the only way that this 2 becomes a 6 is if I multiply by 3. If I do it to the bottom, I do it to the top. So that gives me 4 over 6 plus 3 over 6, which is 7 over 6. That means that this, and this thing kind of got in my way, my apologies. I'm just going to have to come down here like this and say this equals x to the 7 over 6. That is that answer in exponential form. If I asked for it in radical form, so this is the exponential form because it has an exponent. If I asked for it in radical form, the 6 is the denominator. That means that's a 6th root. And that 7 power could either have been inside the radical or outside with a set of parentheses, like you saw me do up here. It's completely up to you. This just has less stuff to write, and that's the only reason why I wrote it this way. Now, in the homework, you don't have to give me both answers, both as exponent and radical. But I can tell you for the test, you want to be able to represent them as either radicals or exponents. The answers to the homework are on the homework. Because there's no way you got the answer without showing this work. So make sure you're showing your work. If you don't show your work, I'm going to give you your homework back and I'm going to give you the opportunity to actually do it and show the work. If you just write the answers, that's a no-go. Not if you want open note tests. Okay? If you want open note tests, you're going to actually do the work. Sir? This homework? Not due tomorrow. It's due Wednesday. Tomorrow's a practice day. And then on Wednesday, the lesson that we're going to start on Wednesday, we won't even finish the lesson until Thursday. And then Friday's the practice day. So Wednesday's homework isn't even due till Monday. You have 2 homework assignments this week. One is due Wednesday and one is due Monday of next week. So I'm giving us lots of time to practice because I know there's probably a million questions about what's going on here. I encourage you to ask me questions. I know fractions are not everybody's friend. I don't know why. I love fractions. I hate radicals. They suck. This is yuck. This is pretty. But that's my opinion. I always thought one of these years, when my kids get a little bit older, I don't know if I told you this yet or not. For Halloween, we always do themed costumes. Did I tell you that? Okay, so I told you that I wanted to make us all fractions because they're scary. Yeah, I'm going to do it one of these days. This is where I am. It's going to be fun. Okay, well, maybe it's just fun for me. I think it's hilarious. Maybe next year. My kids? I don't care. I'm their boss. I don't care if they like it. I tell my son all the time, I don't care what you want. You do what I say. I say it all the time. Nobody cares what you want. You're a child. Do what you're told. I say it often. The 7-year-old thinks that he needs to have things to say when I tell him what to do. And I tell him, son, that's not what I want to hear right now. I want to hear one thing from you. What is it? Yes, Daddy. That's what I thought. Go do what I said. Very simple. Do what you're told, and we'll talk about it. That's how I was raised. Okie dokie, smoke. Let's do another one. Unless you guys want to talk to me about it. I mean, what can I help you with? I know fractions not everybody's strong suit. Ask me a question. It is pretty straightforward. What's the hard part? Fractions, right? If you can convert radicals to fractions, then you have learned what I needed you to learn. Because honestly, adding fractions is supposed to be old knowledge. So if you are comfortable converting radicals to fractions, sweet. You understand the algebra too. Then we just have to work on your fraction skills, which is not algebra 2, and that's good news for me. Alrighty, let's tackle this one. Again, convert the radicals to fraction exponents. This x does have an exponent. It's a 1. So on the top of my fraction, what is the power of x? What's its exponent? Yeah, it's a 1/4. And the bottom, what's that exponent? 5/8. Let's talk about pizza for a second. Large pizza cut into how many slices normally? 8 slices normally, right? So if you had a quarter of that pizza, how many of the slices would you have? 2 of them. So what's bigger, a quarter or 5/8? 5/8 is bigger because if you had 5 of the 8 slices of the pizza, you're very, very full. The reason why I'm asking this question is because I'm trying to get you to remember the trick. That's like, okay, where is there more x's, on the top or bottom? That's whichever one has the bigger exponent. 5/8 is bigger than 1/4. That means in the result, I won't have any exponent, or excuse me, any x's on the top. All my x's will be in the bottom because 5/8 is larger than 1/4. So I get 1 over x to the, and when you divide two numbers with the same base, what do we do with their exponents? subtract. And since we've already decided where it's going to be, we're always going to do bigger exponent minus smaller exponent. So it's going to be 5 over 8, oops, minus, sorry about this errant symbol, 1 over 4. Oh man, they actually have a really nice common denominator. What's the common denominator? It's just 8. So I don't even need to have a secondary set of information. I'll just go ahead and multiply the top and bottom of this by 8 right here. By 2, excuse me, so I can get it 8. And that gives me 1 over x to the 5 over 8 minus 2 over 8, which is 1 over x to the 3 over 8. Or you could have written it as x to the negative 3/8. Nope. Both they say the same thing. And I could also write these in radical form. I could say this is 1 over the 8th root of x to the 3rd. I could call it the 8th root of x to the negative 3. There's so many different ways of writing it that are all correct. Again, the answer that I want you to find is on the homework, so you'll know if you did it right or not. I just want it in, the format that I gave you. All right. Oh boy. Okay, that one's a little tougher to set up, isn't it? I mean, the other ones that you saw us doing, we were taking the exponent and putting it on top of this number, weren't we? But this exponent's already a fraction. Shucks, shoot, darn. What do we do? Well, I could write it as 6 over 5 over 4, but yuck. Or I could write just the radical as an exponent. I could write the 4th root as an exponent. And what kind of exponent is it? Just the 4th root. That's 4th power. I need the 4th root. The denominator is the root type, right? So what would be the top of that fraction then? It'd be a 1/4. You see, the root type is always the denominator of a fraction. The top is at least a 1. It could be more stuff. It could be a 5, it could be a 2, but the point is, this is a 1/3 power, this is a 1/4 power, this is a 1/8 power, that's a 1/4 power. And there just happens to be more exponents going on. You see, what you didn't see me do right here was write this as x to the 5th to the 1/8, which is what I was trying to show you right here, that it could be separated. Yes, sir?
So how come when you have like the power of 2 to like root 3,
Mm-hmm.
how come you did 2 over 3 if here you're just putting a 1?
Well, so right here, I could have written this as x squared to the 1/3. Now let me ask you, when you raise a power to a power, what do you do with the exponents? Now that's when you multiply two numbers at the same base, you add the exponents. But when you raise a power to a power, what do you do with the exponents? You multiply. And what is 2 times 1/3? Mm-mm-mm. If you had a 1/3 and then another 1/3 and you put them together, you'd have 2/3. So you would have gotten 2 over 3, which is right there. So actually going from this to this is a shortcut, skipping over this mathematics. But this mathematics was happening. See? So here, what we're going to do is we're going to multiply these exponents. So I have x to the 6 over 5 times 1 over 4. Because when you raise a power to a power, you multiply those exponents. x to the. Now when you multiply fractions, you go straight across the top and straight across the bottom. So 6 over 5 times 1 over 4 gives me 6 over 20. And then you just have to reduce the fraction. What can I divide 6 and 20 by? 2. So I just divide them both by 2. I get x to the 3 over 10. Or the 10th root of x to the 3rd, whatever you want to write it as. But I like exponents. I hate radicals. Radicals suck. They are not fun. So recap before I go on to evaluating things. I started the lesson, and you don't have to write this, I'm just showing you. I started the lesson with this setup. What I could have done was I could have showed you that this root type is a fractional exponent. Like that. Which is also the same thing as, because order of multiplication doesn't matter, that. Either way, you're going to get that. Is that a better setup? A better explanation for you guys?
Wait, why you stop me?
I was just showing you that I can, because the order of multiplication doesn't matter. Because either way, I was going to multiply them. You guys ever wonder why a square root cancels a square? Or did you just trust it? My teacher said so, honestly.
I mean, I know that like square root is multiplying something by itself.
But isn't that such an abstract idea? I say, hey, what's the square root of 25? Let's just say you don't have it memorized. And you go, okay, something times itself must have given me 25. Isn't that a really abstract way of thinking about it? Yes, it is. Come on, yeah, it is. Why does a square root do what it does? Why? Because we said it does? That's not how math works. No, 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 no. Remember I told you at the beginning of the lesson there's no such thing as a radical. There is no such thing as a square root. There is only fraction exponents. Let me show you what I mean. Can we all agree, for the sake of argument, that 25 is 5 squared? Can we all agree to that? Okay. For a moment, just take this trip with me. So we can all agree that the square root, we've already talked about this, has an index of 2, correct? So the square root of 25 is the same thing as saying the square root of 5 squared, right? But wait a minute. Now that we are armed with today's knowledge, we're not going to say square root. No, 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 no. What we're going to say is raised to the what power? 1/2. Tell me, what is very special about the numbers 2 and 1/2? What are they known as in mathematics? You're not wrong, but I mean like 1 and, or I mean like 3 and 1/3, 4 and 1/4, 5 and 1/5. What do we call these things? It starts with an R. Two over 1 and 1 over 2 are reciprocals. What do we get when we multiply reciprocals? Oh, you get a power, you get a 1? Oh! You see, that is why radicals do what they do. They are the reciprocal exponent. That's why they cancel them. That's why square roots cancel squares and third roots cancel thirds, because they're reciprocal exponents. A third root is a 1/3 power. That's why it cancels third powers. They're reciprocal exponents.
Like I gained sacred power.
Should. It should feel like a true mind bomb. Like, oh, that's why those do what my teacher said they do. You see, unfortunately in mathematics, there are some things that we can't teach you why it's true when you're young. We just go, hey, here's this thing that math does. and we ask you to be good with it. Unfortunately, sometimes there are mathematics like that, and then when you get older, we can go, okay, now that we have learned a bunch of math, let me go back and show you why that thing was true that you just accepted. This is why radicals cancel exponents. It's a matching exponent. When the index matches the power, they straight cancel each other out. That's why I had you doing this earlier in the year. Because this is a 1/2 power and this is a 2 power. They're reciprocals. That's why I was making you do that. Neat, right? Mind bomb. No such things as radicals. It's just another way of writing a fraction exponent. So you're looking at this thing and you're going, evaluate the expression true. Let me grab my calculator. No, don't you touch that calculator. You can tell me what the fourth root of 81 to the third power is without a calculator. Who knows what 81 to the third power is? Notice I didn't raise my hand because I don't either. I don't know what 81 to the third power is. It's a huge number. It's big. But I can tell you that the answer to this question is 81. Not 81, my apologies, 27. But how'd I do that? I don't have any notes sitting next to me with the answers. How'd I know that that answer was 27? The way I did it was I realized that the order of multiplication of the exponents doesn't matter. So I could either take 81, raise it to the third power, and then take the fourth root, or I could take the fourth root of 81 and then raise it to the third power, because they are both exponents, and when you raise a power to a power, you multiply them. Order of multiplication, unimportant. That is another reason why I showed you this again. You can switch them. This A can be written inside or outside, whichever one is more beneficial for you. Now I'm hoping that lots of people know what the fourth root of 81 is. It's one of the ones I asked you to memorize. It is 3. So this thing right here, this is all just a 3. So this question actually says, what is 3 to the third? 27. Wow. Neat, huh? I don't know what 81 to the third power is. No clue. It's a big number. No, that's the thing. Okay, this does say 81 to the 3/4 power. It does say that. So what I did was I chose the order in which I wanted to use those exponents. I chose to do the 1/4 power first, which is what you saw me do right here. I did the 1/4 power. I got the answer of 3, and then I cubed my 3. What's up, Nick?
So you couldn't do just like 81 to the third, like 81 to the power, like, 3/1 times 4/1?
1/4.
1/4.
Yeah, this is the 1/4 power. And you could on a calculator.
Oh, wait, no, that gives you 3/4.
Yeah, you could do that on a calculator. If I remember correctly, your next test is no calculator, though. So,
Oh, yeah, 3/4 of 81 is 27.
no, not 3/4 of 81. No. 3/4 power. That means take the fourth root, which we did, and got a 3, and then raise that 3 to that third power. Maybe we should practice that one again. Let's do it with it. Let's make up another question real quick. How about the number, I like the number 64. It's a special number. And let's do the cube root of 64 squared with no calculator.
4. 16 times 4 is, well, 4 times 4 is 16, 16 times 4 is 64, right?
Right.
So it's 4, or the cube root is 64.
Right. So what Nick is saying is that it'd be much easier to do the cube root first, because I don't know what 64 squared is. I know it's big. I know that. I don't know what it is though.
And then to the side to the power 2.
And then we would square it. Nick's already said that the cube root of 64 is 4. So it says 4 squared, which is 16. Pretty cool, huh? All right, now the last example is how you're going to approach, how you're going to do the last question in the homework. Homework is not due tomorrow, it is due Wednesday. There are 12 homework questions. And there's a sentence next to number 12 that says, students that skip number 12 cannot have more than half credit on the homework. I don't care that this looks scary and hard. You will try, or you won't get more than half credit on the homework. That doesn't mean that one question is worth half of the credit. It's a filter. No, I said if you don't try it. You got to try. And I'll be real with you. I didn't even make this question up. I took this question from the Algebra 2 end of course exam practice that we used to have. Back when there was an Algebra 2 end of course exam, that was the kind of crap that was on it. This came from the practice test they gave us. Aren't you glad you don't have to take it? Every time I show you one of these, it's just like, holy crap, what drugs were they smoking when they wrote that, right? There's a reason why you only needed a 23% to pass it, and why only 40% could get 23% right. Because it was hard. Or it looked hard. This looks hard. I'm telling you, it's not. I promise you, it's not. Mr. M, that x plus 5, oh my gosh, who cares? Notice that it never changed. It stayed an x plus 5, didn't it? So why was it there? To screw with you, that's why. To make the question look scary. But it doesn't need to be. What we're going to do is we're going to figure out what A and B equal to make this a true statement. What is the index on this radical that's not written? 2. On the left side, can we all agree if we were using this as exponents, this would say x plus 5 raised to the 4 raised to the 1/3, because that is the cube root, raised to the 1/2, because that is the square root. That was just the left side of the equation. I took this and I rewrote it with no radicals. Nope, and the order of the exponents is unimportant. I do want to remind you that this 4 is a 4 over 1. The x plus 5 is just an x plus 5. Do not let it mess with you. It actually means nothing. It's completely unimportant. What am I going to do with these 3 exponents, because it is power to a power? We're going to multiply them. When we multiply exponents, fractions, we multiply straight across. The top then is 4 times 1 times 1. The bottom is 1 times 3 times 2. And this 4 over 6 reduces. I can cut them both in half. And get a 2/3. That's what the left side actually says. The left side actually says x plus 5 to the 2/3. That's all it says. So much simpler, isn't it, written like this? That's the whole left side. Now what we need to do is figure out what the right side is. The right side when we multiply two things with the same base, and they are the same base, the base is x plus 5. When we multiply two things with the same base, what do we do with their exponents? Algebra 1. When you multiply two things with the same base, what do you do with the exponents? You just add them. That's what the right side says. So what you were actually told is that this blue thing equals this purple thing. No, it's not that I took it away. If I said x to the third times x to the second, wouldn't you just say x to the fifth? It didn't go anywhere. It didn't take it away. They had the same base. So I write it one time. So the only way that this blue thing equals this purple thing, the only way this and this are exactly the same thing is if their exponents are the same, right? So what this question actually said was, can you solve this equation? This is what it actually said to do. So if you wanted to get a and b by itself, all you do is subtract 1/5 from both sides. I'm running low on space here. This gives me that a over b is 2 over 3 minus 1 over 5. I left space there for a reason, because what is required in order to add or subtract fractions, guys? They need the same denominator. I need the least common denominator. What is the smallest number that 3 and 5 can become? It is 15. We need to get a 15, so we multiply by 5 top and bottom, multiply by 3 top and bottom, and what I get is a 10 over 15 minus 3 over 15, or 7 over 15. So A is 7 and B is 15.